All right, so we have a cute little cat. Is that a cat? I'd say it's a cat. Let's make our cat walk. This should be fun. Okay, a few things we'll do first, actually. I want to make 4 different new states here. We're going to have an idle state because it seems weird that the cat is walking but not doing anything. Now, in some animation packs, you actually have like an idle state that has, movement, like they're kind of just shrugging their shoulders or whatever. We don't have that in this graphics pack. So what we're going to do is use the same sprites, but instead just use just one frame of it. So they'll kind of just be sitting still. So if we have that, we also need to, of course, kind of duplicate our efforts here. So we're just going to change all of these to idle. And we'll go down again. I'm putting idle before walk. It just makes more sense in my head to have that one first. And here we can just do this. Idle. And what else do we need? We need stuff for animations. So we'll do that same sort of process. Command D is your friend if you have a Mac. Otherwise, Control D is your friend. And its current state, instead of walk down, we'll use idle down. So let's save that and just rebuild. And you'll see now our character is just kind of chilling there in its idle state. Okay, let's get some movement going. So first of all, to do this, we are going to add a few more mix-ins here. So we already have the has game ref mix-in, but we want to have also the keyboard handler. Okay, so we'll add the keyboard handler there. And in the game itself, my game, we also have to add the mix-in, which is called has keyboard handler components, so that those keyboard events actually get passed through. And that comes from, I think either of these will be fine. We'll find out. So we'll have that. Now, let's actually create now, because we have this mix-in, we have this new thing we can override. So let's do this maybe after onload. And it is called on-key event. So on-key event, we should get the autocomplete. And yeah, this is just part of that mix-in. And what we want to do in here is we still want to return this right here, but we want to check some things. So the first thing is we want to know, is the left key being pressed? And we'll just make a variable called is left key pressed. And we can get this by looking into the keys pressed variable here that gets passed in on each frame. And we want to check if it contains, and we can use logical keyboard key dot key, what would it be? Arrow left. Now, because this is a PC game, at least right now that I'm making, we can also check, and I'll actually do this as the first one. We want to check if it's just called key A, because we're going to have like the WASD option as well for people to move around, which is a lot more, ergonomic and pretty common in video games. So we'll have that. We'll also have is right key pressed, and for this it will be key D or arrow right. Okay. Now we will obviously be doing the same thing for up and down, but we want to, I'm going to do this in kind of a more interest. Actually, no, yeah, we'll just, screw it. We're just going to do this. So is right key, or is up and down. I'm just going to paste these in because you get the idea. We're just checking W and S or up and down. Okay. So just to see this in action, let's print is left key pressed. And if we actually go to our debug console now, let's just make sure everything's hooked up. We see this. Now, you might not hear this because I'm not streaming the audio on my computer, but there's kind of this weird tapping sound happening. And it's because, at least on Mac, I don't know if this happens on Windows, we're not really, Flutter's not handling that key event. It's like, I don't understand that. Even though Flame can understand it, there's something weird. So the solve for this, and maybe there's another way, but we're actually going to go to our main.dart. And instead of just running and returning a game widget here, we're actually going to return a material app. So we're kind of going back to what we would think. And then this becomes home. And we want to make sure, now we have a material app, we want to make sure our debug checked mode banner is false, so we don't get that annoying little thing in the top right corner. And now what we'll do is we're going to wrap this in what's called a focus widget. And our focus widget allows us to have an on-key event that essentially we get two things. We get a node and we get an event, and we just return what we want to do with that. And what we're just going to do is key event result dot handled. We're going to basically say, yeah, we handled it. And then the cool thing is now we're not going to get that sound anymore if we actually green arrow restart. So boom, 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 boom. Now I'm not hearing that sound, and we're good. So just keep that in mind. If you're annoyed by the sound that's being made, you got to do that, at least on a Mac. So we're seeing sometimes true when I'm holding it down and false otherwise. So that seems to be working. We'll take out that here. Okay. Now, before we get into all the logic here, what we need to do is actually set up some variables. So currently we have some late variables. In this one, we don't really have any positional or variables that would be passed in. So I don't have those that I would normally put here. We might at some point. But the third type of variables that we care about are basically our non-final variables. And these are things that are actually going to update, in potentially every frame or when an event happens or that kind of thing. So a few things we want to have here in no particular order. The first thing will be a vector2 representing the starting position. And there's a reason we need this. Oh wait, sorry, we already have that. We already have that one. Look, yes, starting position we already have. Okay, so get rid of that. But we do want to have a vector2 that represents velocity. So velocity is essentially like the speed you're moving in a particular direction. And we're going to actually instantiate this as a vector2 dot 0. So just a shorthand to basically say 0, 0, 0. A real shorthand there. Okay, so we have that. And then we're going to have our double, we're going to have our move speed. Right, and our move speed, we'll just set it to 100. This could be a constant you put in another file, or it could be part of maybe, something you pass in, maybe stats, whatever, but we're just gonna make the move speed 100. Seems like a good number to me. All right, then what we want to be tracking is how much are they moving on the horizontal at this given time, at any given time. And we're just gonna make it 0.0. And we also want one for vertical because our player can technically move, in either direction. And the last thing we want to track, we want to be knowing essentially which direction were they last facing, so that when we do turn events and stuff, we can do that. Now, what I want to do is actually create a very simple enum for this. And I'm just going to paste it in because it's so simple. It's just something called walk direction, just so we can kind of work with them, like this. Instead of using strings or whatever, we can get some autocomplete. So we're going to have something called a walk direction, and we're going to start it, or what are we calling this? We're calling it last walk direction. And we'll just initiate it with walk direction dot down because that's the way they're kind of facing, right, when we load the game. So that could also be something that you dynamically pass in as like a starting thing, as we talked about in the last video. But for now, we're just hard coding it as that. Okay, so that's cool. We have all this stuff. We have all that. And yeah, so basically now we need to kind of control how much they should be moving and their velocity. So we're going to do that in our onKey event, essentially changing the velocity and whatnot. And what we'll do first is let's just make sure that the left key and the right key are not being pressed. So if is left key pressed, and I'm going to kind of try and explain as I go, but I think when it's all written out, it'll make a little bit more sense. So we want to make sure that they're not pressed. And if they're not pressed, that's kind of where we can just at least make this a little more efficient. Because the reason is if either of these are pressed, we're essentially, we don't want our character to walk on angles in this game. You might make a game that does that, but you would need a sprite, that has like the sort of like different angles. So we want to check if neither of those are pressed, then we're going to check, the up and down keys. And what we can do is we can take that vertical movement and we can go plus equals. We want to check if the up key is pressed. We're going to essentially go -1 because we want to move up like negative. Otherwise, nothing. We don't want to change anything there. And we want to make the vertical movement also if the down key is pressed, we essentially do the opposite. And what's kind of cool about doing this way is if both are pressed, like say you're just pressing both, then these will end up like canceling each other out. So you actually will end up with 0 anyways. All right, cool. Now, what we want to essentially do is we want to track essentially the last direction they are walking. And this is going to be helpful for changing the player's state, as well as when they do a collision in the future, and so on and so forth. So let's just check if the vertical movement at this point is greater than 0. So basically it means really we're going down. Then we're just going to say the last walk direction is equal to walk direction dot down. Then we can go else if vertical movement is less than 0. We don't want to just do a straight else because that would always happen and they might not be walking at all. So, if it's 0, and here we would just do up. So we'll have that stuff there, which is cool. So we're setting that stuff, we're setting the vertical movement. Now, in the case that one of these is being pressed, that's where we can kind of go in here and really do almost the same thing except with the horizontal. So we'll basically update the horizontal movement if the left key is pressed, if the right key is pressed, and that same kind of canceling out. And then also check this. So the reason we kind of do this check at first is if someone's like, button mashing or whatever, we kind of have to pick one to be like which one takes priority, because we don't want to. It just feels better on the keyboard when you push another key that it's not canceling out. It's at least choosing one of them. So I don't know if that makes sense. You can experiment. You can try this in the opposite way. You can try it by just not having this check first and just kind of seeing. But this is what I feel. I feel like this just works nicely. So really all we've done here is set the last walk direction, which isn't really doing anything yet, but it will. And we're like updating this vertical movement. How much are they moving right now? Okay. So now that we have this keyboard handling happening, which is just not actually affecting our player, we are going to actually start to affect our player. And we're going to talk about another method we've never updated yet, or sorry, I said the wrong word. I said the word that I was typing that we've looked at yet. It's called the update. So onload only happens once when an instance is loaded on the screen into a map or whatever. Update is happening every frame. Now, when I say the word frame, it's not necessarily the frame that you think of in FPS. It's like the game loops frame, which can actually be faster. I imagine it could be slower than your actual like rendering frames. But this is the game loop. This is going to run a whole lot. It's just always running. So you want to be careful in here. You don't want to do anything too crazy because it will slow everything down. So what we can do in here is now we want to actually, based on that movement speed, actually change their velocity. So what we will do is we'll take velocity.x is going to be equal to whatever the horizontal movement is right now, times our movement speed, which is just that constant, more or less constant that we made here. Then we want to take and update its position. So position, it's not something we made here. It's part of just a sprite animation group component, or really any component. And what we will do is set its position.x equal to, and we'll take the velocity .x, whatever velocity in x is going, and multiply it by the dt. And why are we doing this to the dt? Because this is actually giving us a double that is kind of accounting for what frame, what part of the loop it's in and whatever. It's your delta time. And we want to account for that to keep things like sort of normalized. Now, we want to do the same kind of thing with y. So I'll just copy this. So velocity.y will actually be the vertical movement times the move speed. And position.y will be whatever the velocity y times the delta time is. And there we have it. I think this is enough to get our player to actually just like at least move on the screen. Now, what I'd like to do is, because we're going to have probably more things in our update, similar to onload, I like to keep this really clean. So we're actually going to do update player position. And we will pass in dt there, so it has access to it. Dt, command dot, create a method. And I'm going to put this in a better place. I feel like this kind of lives around the update area. This is all key event stuff. Yeah, I think it should go right here. Okay, so let's see if that's doing anything now. There we go. So I'm holding it down, I'm clicking. It's like moving along. It's pretty cool. So a little bit janky. I think I might have, there's something weird happening. I'm going to double check my code in a moment, but let's finish that, or let's, try and finish this up. So it's moving, but we obviously wanted animations and to, reflect things. Yeah, there's something weird going on here. Let's just refresh here. Okay. Now, how do we do that? So we're going to essentially have another thing, and we'll do this actually before updating its position. We're going to have update player state. So what state is it's in? We don't need a DT for this. And let's do this as a method and put it, might as well put it right here. So our update player state is essentially going to, set its state, and the state meaning like really this, which correlates to the animation. What we're going to do is essentially set a default state right off the bat. And we're going to call it player state, or we're going to reference the type player state and call it player state. And we're actually going to use a cool little switch function here, which is, newish in Dart, newish, not super new. And we're going to check with that last walk direction, because based on where they were, how they were last walking, say they've stopped, we want them to be still facing that same way and using that. So here, it's just going to be a simple switch where we can do, walk direction dot down. We want that to map to the player state. Player state dot idle down, because this is like kind of like, hey, they're not walking. We're just getting this set. And we'll do the same for up, left, and right, just like that. And yeah, this is a cool way you can kind of use like a switch to, to do this then in way less lines than you would otherwise. Okay, so now we just kind of set that, but we haven't actually set the state. Like, at the end of this, we're essentially going to go current, just like we did in the onload, is going to be equal to this player state right here. But what we are going to do now is check some things. So let's check if the velocity.x is greater than 0, then we're going to have player state is going to be equal to player state dot walk right. So we're going to use the walk right animation. Similarly, we'll check if it's less than 0, if y is greater, if less, that kind of thing. So we'll have x being greater, less, so we have left, right, da, 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 da. Makes sense? Cool. So now, if we save that and go to our game, we'll actually see that they're moving. Now, there is an issue here because, well, for one, going the wrong way, it's, definitely made some typo somewhere in this. And I can tell it feels jankier than usual. Something weird is happening. I'm going to review right now and circle back. All right, upon review, I think I know the issue here. On the onKey event, we want to reset our horizontal movement always to 0. Because basically what's happening is we're kind of taking it from the last frame. So we want to set that and the vertical movement, of course. Because remember, this is just something that's going to basically, these will only ever be -1, 0, or +1 for any of these. So we want to reset back to 0 because what's happening is it's kind of, not resetting it. I don't know how to explain it better than that, but I think that's the issue we're having, why it's doing weird things. Let's find out. Oh wait, no, it's even worse now. Now it's even worse. Okay. Eureka! I was also wondering why is our player getting moved to this top left? And I didn't think we shouldn't be just like setting the position. We should be adding its x position, adding its y position here. So plus equals, and that is exactly the problem. And let's rebuild, although we wouldn't have had to for this because it's in the update loop. But now we are working perfectly, and it's much smoother. Yep, this is great. Okay, so yeah, we have our player here, and they're walking around, and no collisions yet. We're going to get to that next, I think. But this is cool. And when you stop, they kind of stop in the idle position that we kind of planned for them based on their last walk movement. So yeah, this is perfect. This is a game, or at least the start of a game. So thanks for watching, and we'll get into collisions next. See you there.